good morning or good week whenever you're watching this. I don't see any names in chat, but if you're out there, good morning to you. Thanks for being here. Dynamite, good morning, Dynamite. Nice to have a little bit of company. Hope everyone is well. I hope that you have some way of enjoying a little bit of downtime or something that gives you pleasure or relaxation this week. For Butte College, of course, we always conduct courses during Thanksgiving week, so apologies about that, but it is sort of factored into our delivering content to you and our workload as teachers. Good morning, Justin. Yes, unfortunately, that means this is a regular week, but you'll find that there's fewer questions than normal because they're asking you to try out some experiments with shell scripts. So hopefully you've got that well in hand. So week 14 feels good. So as I've said before, the remaining weeks are all about just adding to our knowledge about how to craft shell scripts using the bash shell. So we're adding conditionals this week. All we mean by that is that we can, you might know of them if you've had some programming as decision-making constructs or decisions. So if statements and what are called case statements. You may have seen a switch in a programming language. So, pardon me, there's really just two ways to do decision making or conditionals in bash. That's with if type statements and then case type statements. So we'll add those to our toolkit this week. I also I'm going to go ahead and at least get a little bit of a start on desktop environments. So that'll be optional material at the end. I'm not going to go for a full hour this time. I'm just going to point you at the instructions that I've tried to clean up so that you can access them at your leisure. Okay, so week 14. So next week, week 15, we'll continue to add to our toolkit of bash scripting skills. It's roughly 2 weeks from now is when the second team project is due. It's exactly the same as the first, so hopefully you can schedule out yourself part of an afternoon or part of a morning or an evening and pick a distribution just like you did before, do a basic evaluation of it, a little bit of research on it, and hopefully now that you know what's coming, since it's exactly the same as the first team project, that won't be stressful or burdensome. Then we have week 16, which is the sort of the final week of new content. And then the week of the final exam, I'll do a review broadcast like I did for the midterm, and then you'll have the final exam during the last week of classes. So that's very little left for us, actually. So let me go to the modules. Well, let me show you a couple of things. So on the guides page, I added a couple of guides. So I cleaned up my text instructions for the window manager walkthrough. Let me just show you what that looks like real quick. So I cleaned that up, and if you have or haven't done the window manager content, hopefully this helps a little bit. All the commands are in here. A reminder about cloning your virtual machine before you mess with it. And then installing the XFace, installing OpenBox, installing i3, which is the hard one because it's got this big mess. And then the basics of using i3. So anyway, those are the same instructions we worked through together the first time when we did an extra hour broadcast for that. So I made a guide for that, and I also have a guide, and you'll see another link to it today, for installing full-on desktop environments. So this repeats the XFace instructions, which if you already have XFace, then you don't need to do that part. But then it also has instructions for display managers, which is what they're called in Linux. A display manager, though, is what you'll think of as a login screen. But in Linux, a login screen is also the place where you can select which graphical environment you want to log into, or if you just want to log into a terminal environment. So I'm going to take this far enough so you can see what that looks like. But a display manager is basically a login screen where it gives you the option as you're logging in to select which graphical environment you want, which I love about Linux. Then there's some additional instructions for installing additional desktop environments. Cinnamon was the voter's choice. I tried Budgie. I didn't have any luck with Budgie, so it installed, but without errors. But I'm not getting any screens, so just a heads up about that for those of you who are interested in Budgie. You may need to do some internet research to figure out what's wrong. And then trying out some different login screens or display managers. So anyway, there's a whole guide for that now on the guides page. And then I have also, just so you can see that, on the modules page, way back in week 11 when we did the window managers, if you go to the reading and lecture page, I added a link to that same file. So if you're going back and reviewing the old lectures, week 11 was when we did the full extra hour and we did the window manager, so I linked that same instructions file to that page. And then this week, you're about to see, I also linked the instructions for the supplemental or the optional material for this week. Okay, so that's a lot. Anyway, the point is I'm going to do just get started on installing, actually executing a login screen / display manager at the end of the regular content this week. Okay, so now to the regular content. So we're going to use if and case statements to control the flow of shell scripts, make decisions, or do conditionals, however you like to think of that. Having the ability to make decisions inside of a shell script means that we can react to situations as they occur while our shell script is running. We'll also look at how do you do comparisons of strings and numbers in a shell script. They're different. And then finally, how do you make shell scripts that you can pass data into? We'll do that as well. So it shouldn't take too long, I don't think, to sort of cover that. Okay, so here's what I was talking about. That same guide for installing display managers in desktop environments, I've linked to the readings and lecture page. So if you want to do that optional content, the instructions are all there. I'm not going to go through all of them, but hopefully everything that you need is there, and I've tried them all out. Everything worked fine for me with the exception of Budgie Desktop, which I only get a black screen, and I have to shut down my system to get out of it, so maybe you'll have better luck. All right, so the lab as usual, pardon me, but there's fewer questions this week, so I think there are 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 questions. A lot of them are asking you to write shell scripts or use shell scripts in different ways, so I'm trying to sort of use the lab questions as extra instructional material. So hopefully this will give you a chance to try these scripts out on your own system. If you're not good at VI or text editing, then you'll get more chances to experiment with that. But I thought since I want you to get a feel for how these things work, I thought I would just give you more scripts to play with in the form of the lab questions. So that's the labs, but anyway, only 10 questions, but they all have scripts with them. So that may take some time typing, but hopefully that reduces the stress because you just try it and you do a little bit of reading and lookup and you should be good to go. The discussion for this week is asking you to go out onto the web, and I've given you an article to look at, but This is especially true for the system administrators in the group. You probably already have a handle on this, but if you're just entering into the world of system administration, then it can be helpful to know what do system administrators use scripts for. So that's what the discussion is all about, is for us to come together and sort of share what we discover or what we know about how sysadmins use shell scripts. They are indispensable, in my opinion, if you're a system administrator. You're going to end up creating scripts to automate or simplify some of the tasks that you find yourself performing on a regular basis. And then the reminder, so as always, the lab and the discussion. Apologies that this happens during Thanksgiving week for some of you, but we are required to work and deliver content this week, so apologies for that. And then the team project, which I put after, a week after, so it gives you time to maybe do a little bit of communication with your team, but you can probably, you know how long it's going to take. You can coordinate with your team members. Don't forget, if you get abandoned by the rest of your team, I will step in and offer my services as your supplemental team member, so I'm there to help if you need it. Okay, so shell scripting. I want to point out to you before I switch my view. So I went to the Linux documentation project, tldp.org, to find this file test operators page, which I'm about to use in scripts. And it has a whole bunch of, well, this one doesn't have a whole bunch, but this one has some examples. So you're going to see me use some of these file test operators. And it's handy to be able to find them. They are, you can Google it and you'll get a link to it, but you'd say, what did I search for? Bash file tests. So that's what I Googled. The first link was the Linux documentation project, which took me into the advanced bash scripting guide. So that's handy because you could go to the table of contents and see other stuff. But anyway, I will be referring to this just so you know. You won't be able to see it on my screen, but I have these in my view, the bash file test operators. Which should be, I think, in your reading also, but I'm going to play around with these a little bit. Okay, so most are getting, good morning, Tim, nice to see you. Most of the shell scripting skills are just a matter of experimenting. So the main things to remember when you are experimenting with shell scripts is to not delete things. Most other things you can get yourself out of, except for if you use the remove command indiscriminately. So the other thing you probably shouldn't do is actively edit configuration files. So when I'm experimenting with shell scripts, before I ever actually fire off commands that change files or remove files, I usually use echo statements to kind of ensure that the script is kind of functioning how and where I want it to function. So just some heads up about that. Be careful about changing things in your shell scripts until you've done some experiments with some files and directories that you don't care if you destroy them before you actually apply them to the system at large. Okay, so let me switch over. Hopefully that's not the screen that I want, so let me fix that. If I switch it off and then switch it back, okay, there we go. I get it. Okay, so I have some notes here on the side. I'm actually going to do it in the opposite order of how I wrote it on Canvas, because I want to keep it simple and then sort of grow it, sort of move toward more complicated. So we're going to start with arguments to scripts. Not that, this. Okay, so let me get logged in. I gotta get rid of that. That bash profile running thing is really irritating me. So let me just show you the ways you might go about making this fix. So if I forget what file that's in, one thing I could do is use grep and look for, like, the word running is probably unusual, and I'll look in all of the files. So that wildcard is actually only looking for regular files. It won't look for hidden files. So if you want to look through the hidden files, you need to tell it with your grep that you're looking for the hidden files. But anyway, I just wanted to remind you that this is a place where grep could be handy. If I don't remember where I actually made that output happen, I can use grep to find the file, which it's my .bash profile that's guilty of that. So now that I know that, I can open my .bash profile, and I'll just comment that out. Now, technically, this isn't going to matter until I log out and log back in again, but just thought next time I log in, I don't want to see that anymore. So just going to comment it out. This is another kind of thing that I've learned over the years. I often regret deleting lines from scripts, and these dot files are really just scripts that are being read and executed by the shell. So I've learned the hard way over the years that just deleting a file from a script, I often find that very shortly thereafter I wish I hadn't done that, because I either want to restore it to what it was doing before, or it had an idea in it that I can't remember how to do anymore. So until it becomes really, really messy, I usually just take advantage of the commenting feature of bash scripts to disable the line that I don't want executing, but still leave it behind in case it's something I might want to refer to later. So let me see if I did make a folder for this week. Right, I have a few things, but I'm just going to start with a new script. Before I do that, for the shebang line, so I had forgotten, since I hadn't sat down on my CentOS for a week, I forgot where bash is on this system for my shebangs. So user bin bash. Now, when I make a new shell script, I'll shebang user bin bash. So that's why I did that which on bash, because I couldn't remember precisely where bash would be found for my shebang line. And remember, the purpose of a shebang line is to guarantee that the contents of this file are interpreted or executed by the bash shell specifically. That can be super handy, because if you're a sysadmin, you will have users who elect to use different shells. They might use the Z shell or the C shell or the corn shell or fish, or any number of different shells. And if you've written a script that you would like your users to run, this guarantees that whatever shell they happen to be using as an individual user, it doesn't affect the script itself, because the shebang line tells the script, hey, I want to run through bash. Okay, so the first thing is this special variable $pound. So $pound, as you can tell from the echo statement, represents how many arguments were supplied to the shell script. So we're going to save this. I'm going to hit escape. We're going to save this and then go execute this script. And then interpret what this $pound symbol means. So this is a special variable. Bash has a number of them inside of its scripts, but this one is the number of arguments that are passed to the script. And then we're going to play around with the arguments some. So I'm talking a little bit so that you can, if you're typing along, you can get that. So it's $, pound or hash or number symbol. So that's a special variable that represents the number of arguments that have been passed to the shell script. So I'm going to write and quit this. So don't forget, when you create a brand new script, it will not be executable. This is a behavior that's designed into Linux. You cannot create an executable file. You have to go back after the fact and make it executable. So I'll make it executable for my user only. Then do a listing, and now you can see it's green because it's being recognized as executable. So I'm going to execute it. Remember, since my week 14 folder is not in my big P path, if I just type hello.sh, the shell won't find it because it has to look through my big P path. So I have to give it either absolute path or relative path. Relative path is easier, so it knows how to find it. I could, though, also do this. There's the absolute path, so the shell doesn't have to go looking for it. This is where it is. But of course, if it's in the present working directory, then it's way faster to use the relative path to it. So notice it said 0 arguments when I just run it like that. If I put an argument, so an argument is simply the extra information that you put on the command line alongside your script. So I execute the script and then pass it arguments, and then watch what happens this time. So this one up here, hello.sh, no arguments, hello.sh space void, that's 1 argument. So this would be 1, 2, 3, 4 arguments. The arguments can be numbers. So they're separated by spaces, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 arguments. You can do a lot. For me, anything more than maybe 3 or 4 is starting to be a lot. But so we have the ability to launch our script from the command line and send data to it from the command line. So you're used to doing this with commands like the chmod command. We passed arguments to it. We can do that to our own shell scripts as well. By the way, note this. It's spaces. So notice that the shell only sees 1 argument because it is separating them out by the things that have spaces between them. Okay, so that special variable, $hash, tells you how many arguments were passed. So let's now play with them a little bit. So the other thing that the shell does is it takes every argument and it assigns a number to it. So your first argument is, it numbers them. These are called positional parameters, I think. Anyway, this is another special shell variable. $1 represents the first argument to the script. $2, and as many as you give, the shell will just keep numbering them. So that's pretty cool. That the shell makes it possible for us to access the data that was passed in based on its position on the command line. So the first thing they type after the script's name is given $1 and then $2, then $3, and so on. So $hash is the total number of them, and then each individual argument is actually given a number according to its position on the command line. So gonna write and quit this. Hopefully I'm not going too fast. Okay, so now if I execute it with no arguments, let's see what happens. So 0 arguments, and then notice that $1, $2, $3 are just empty because there was nothing there. So if I put my name in here, that's $1, so that's the first argument. The second one I'll make a 10. That becomes $2. I can make a third one, $3. If I do more at this point, of course I don't have any reference to those inside of my script, so they're just ignored basically. So that's how you can get data from the command line into your script, and if you can do that, then you can create for yourself super powerful scripts. Okay, so hopefully that part made sense. And really, I'm just going to do I'm just going to introduce us to the basics of basically, maybe there's 4 more things. Okay, so that's command line arguments. And notice how they're numbered. So now let's do a little bit of conditionals, decision making, and we're actually going to use the command line arguments initially to do that. Okay, so I'm going to comment these out. Just to have those there as a reference. And then show you how I will often. So what I would like to do is write a script that says hello and then a person's name. Now I'm going to replace this, but I want to use what we've just learned to make a good script. So let me show you the problem with this script right now. And what I want really is for them to put their name on the command line, and then I can take the name they gave on the command line and say hello to them. But let's look at the problem and then how we can craft script to deal with the problem. So hello, first argument, I am happy to meet you. I'll hit pause for a second. Okay, so this kind of thing can be super annoying. So let's just say I forget that I'm supposed to put my name, and it says hello, nothing. I'm happy to meet you. Of course, what I want is for them to give me a name so I can say hello to their name. So what we scriptwriters will often do is we will use a conditional so that if they don't give us a name to say hello to, we'll actually give them a brief instruction about how to use the script. So I call those, and most people do, I think, call them usage messages. So let me show you how to do a usage message with a conditional. Okay, so I want to be able to say hello by a person's name, which means that I absolutely have to have at least one argument. So that's the thing that I want to deal with. If they don't give me at least one argument, I need to tell them how to use my script. So the way I would do that is an if statement. And then pay attention to this part because this is super important. After this little square bracket, so wherever I have spaces, so if space bracket, space. If you don't put a space in the right places, you will get errors, which can be off-putting. So I'm going to use an if here, and what I want to know is, does that number, which is the number of arguments, equal, now this is weird, but when you're comparing numbers in a bash script, you have to use numeric symbols, so this means equals. So if this number of arguments equals 0, space, bracket, you probably can't see that. There you can. So the spaces are super important. If space, bracket space, $sign. So if that number of arguments is equal to 0, that's bad. That means they didn't give me a name to print. Then I'm not going to use tab, I'll just space over a couple times. Let me hit enter again. Okay, so if they don't put any command line arguments, there are 0 command line arguments, I can't say hello to them. So what I would typically do is say usage and tell them how to use this script. So, oh, you didn't put a command line argument. What you were supposed to do when you use this script is type the name of the script followed by your name. I put it in all caps, and I'm hoping that the person will figure out that I mean their name. And then I will use a else. Otherwise, it's okay to greet them. So if it wasn't no command line arguments, then there's at least one, and it's safe to greet them. And then you close your decision, your conditional, with fi. So if there are no command line arguments, then they're going to get a message about how they were supposed to use this script, which is to type the script name followed by their name. Otherwise, else, I can say hello to them, and I will. I'm still ignoring all the additional arguments, but that's a basic conditional using if. And then notice you close it with fi. So if this condition is met, then print out this statement, which is no command line arguments. Otherwise, it should be safe to say hello. If they give me more than one argument, it just gets ignored. All right, so let's try it out. So there's my usage message. I provided no command line arguments. The script detected that, and it prints out a usage message. This is what you're supposed to do. So I say, oh, okay. Now the script detects, okay, you gave me at least one, so I can say hello to you. Okay, so that's a start. So it's going to get a little bit more complicated, but while we're on it, I just want to show you this. Yeah, so let's give ourselves a variable. I don't know. Who? Thinking Homer Simpson. So we make a variable here called special, and I just want to show you we can put ifs inside of each other, just like you can in every programming language. But the main thing I want to show you is when you're comparing strings of text as opposed to number values. So the number of arguments is a number value, and I had to use this alphabetic comparison. If you're doing strings, then you can use the normal comparisons like you would in most programming languages. So if you're comparing strings, typically what you're going to do is put quotes around it. Oops, that's supposed to be a 1. So now what I'm looking to see is that string of text that is their name equivalent to, and the reason why I'm using the double equals instead of the dash EQ is because you use the dash EQ for numbers and the double equals for strings. It's just a little bit weird, but you have to tell the bash shell if you mean to be comparing things numerically or if you are comparing them alphabetically. So I have this on the notes to decide. If you're comparing strings alphabetically, then you use the less than, greater than, less than, equal to, like you're used to in programming. If you are comparing things numerically, then you use dash less than LT, dash GT for greater than, dash LE for less than or equal to, dash GE greater than or equal to, not equal to. So we're doing an alphabetic comparison here. Hold on, I need to get the chat back up where I can see it. We're doing an alphabetical comparison between the name they gave us and our special person. Notice here again the spacing. So if space bracket space and then the quotes $1 space double equals space quotes $special quotes space square brackets semicolon. But when you're doing alphabetic comparisons, most of the time you'll see people putting quotes around it. That's just in case there happened to be a space somewhere in there. You still want to match. Then so I spaced that out a little bit. So we'll say hello. Now if they happen to be Homer, we'll say you are special in addition to saying hello to them. I wanted to use this quick example though just so you can see comparing things numerically, which has to use the weird letter style, and comparing just the strings of text alphabetically, which uses the comparisons that you're probably used to from other forms of programming. The other thing, of course, is that you can put conditionals inside of each other. So this conditional, checking to see if they're the special person, is inside of this else for the greeting part as well. So let's try it out. That still works. So now if I put me, it just does the greeting. It doesn't tell me I'm special. But if I say hello to Homer, then I get the extra message because it detects that, oh, your name is Homer, you're special. I'm just going to go make sure that I'm hitting on all the bits. Okay. So that's our most basic of the if statements, comparing numbers, comparing strings, using command line arguments and the positional arguments, the ones that have the numbers that are automatically assigned to them, which is super, super powerful. Now let's do the other kind of decision making and combine it with our hello. I'll just have to sort of think of how do I want to do that. Okay, so I have an idea. So let's see what I got here. Okay, let's make a new one. I'm going to call it tasks.sh. So shebang, to guarantee that this is interpreted by the bash shell and not some other shell. Okay, so I'm going to do a similar setup. Space, bracket, space. So I'm going to write a script. I already know that I want to have this script take an argument. So I'm going to do my same usage check that I do a lot of in my scripts. So usage. And then we might, in fact, I'm going to give them a selection of tasks. So we will say we'll do a cal, or let's do it like this, cal or date. Maybe I should put a space so you can see that's a vertical bar, or date, or count, or greet. Okay, so what I'm telling them here, and in fact I'm going to make that, oops, I need to make that clearer. What I'm telling them here is that you run this tasks followed by one of these strings. So cal or date or count or greet, that's the usage message, and then I'll show you how I'm going to use those things. So with my script you say /task.sh. Remember again, this is if they didn't give me an argument. What they need to do is tell me what task to run. So the cal task, the date task, the count task, or the greet task, which I'm just making up. Okay, so the other way of doing conditionals then is with the case statement. So this one looks kind of funky. If you've done programming, it's like a switch in most other languages. So, but what I'm doing here is I'm actually looking for what this first command is, and then when you do a case, which ends with the case backwards, it allows you to list out a series of matches and what you want to do in the case of that match. So in the case that that first argument is cal, to do, yeah, two more. I will echo, I'm showing you the calendar. And then I'll actually run the cal command. Hopefully that doesn't cause any problems. And then you end that section. So this reads funny at first, but what we're saying is in the case that the first argument is the word cal, then do these things. I will first echo, showing you the calendar, and then I will fire off the calendar command. And to start, I'm going to do the everything else. So everything else, I'll just print out a message saying I can't do that. Okay, so it looks a little bit funky at first, but we're setting up a tree of possible outcomes with multiple branches on that first argument. So if that first argument is the word cal, then it should echo this statement showing the calendar and then actually fire off the calendar command itself. Anything else, which is what the $sign means, it's just going to say I cannot do whatever that word is yet, and then we will add more options. So this is the other way that you can do conditionals, decision making in bash scripts, is with this case statement, which works really well when you have a whole bunch of different options that you might want to have someone run your script with. So this is really a script with these 4 options, even though I haven't done 3 of the options yet. And don't forget that in a script you can run any command that you can run at the command line, which is how this cal is going to work. Hopefully the word on the command line and this don't screw up each other. We'll find out. So hopefully I've delayed enough to let people type a little bit. This is just an example, and there are some extensive examples on the hands-on page that I'll show you, but before we close out, I've got to start watching the time here. So here again, I have to make it executable because you can't create things executable. You have to make them executable later. So if I run tasks with no arguments, I'm going to get the usage message. So let's run it with cal. It worked. So notice it matched the word cal with that. So showing you the calendar, and then it ran the command. Now if I do something else, then it'll just say I can't do that thing yet. And then I'll do one more, and then we'll let's do a count so I can show you how that might work. So we're adding a new option, count. So what I'm going to do here is these are backticks. This is how I'm going to do this. This is how I'm used to doing it. I hope that works. It looks a little funny, so we'll see. Maybe I want to use the newfangled style. Let's try the newfangled style. So what I want to do, we'll see if that works. Those are double parentheses. What I want to do though is capture that piece of data. So I'll do a file listing and then pipe it through wc-l, which will tell me how many files I have. And then I should be able to then echo ooh, let's be super fancy. Can we do this? Yeah, that doesn't work. It might. Let's see if it works. I think it might. So you know what? Let's get rid of this. Let's just do it directly. And then I'll stop and make sure that you have a chance to catch up on me. So ls pipe to wc-l. Okay, so I'm actually just sort of capturing the data in the output. So $, parenthesis, parenthesis, ls pipe through wc-l, which should just count the number of regular files in, and then I do the same thing again. I don't know if it's going to work, but we'll find out. $, and then what I'm trying to do is capture the present working directory output, so it'll say there are 5 files in this directory. If it doesn't work, then we'll go back to the old style that I'm more familiar with, but I'd say we give it a shot. That is count. Okay. Nope, didn't quite do it. Okay, so we will go back to the style that I'm used to, but I'm going to leave it here. I'm going to backtick it. So these are backwards tick marks. They are up on the top left of your keyboard. Which are hopefully capturing the output of that command and then placing the results right here inside of my output, the backticks. So I'm backticking pwd as well, which I'm hoping will mean that it'll show me present working directory, so there are so many files in whatever my present working directory is. And again, those are not regular quotes, those are backticks, which are up on the tilde key on the top left of the keyboard. Okay, so that did work, which I'm super happy with. So there are 7. I should have put the word files in there. So I'm going to go back and do that just so you can see it one more time. This one. Okay, I should have put the word files here. Okay, so I'm using the backticks to capture the output of commands. The other thing you can do with that is you can separate those into variables. So you can separate those into variables and then use the variables in your output instead if you're more comfortable with that. And I thought that might be easier for you to read if you're following along. Okay, so files is a shell variable that contains the captured output of ls piped through wc-l, which should tell me how many non-hidden regular files there are. And then dir is a variable that's the captured output of pwd, and then I use those 2 variables in my echo statement. So some people prefer to script this way because it's a little bit easier to see what's going on without a whole bunch of sort of nested mess. Hopefully that's enough of a pause so I can save and quit. Make sure that that works. Okay, so anyway, that's my little task script. It uses that case statement to figure out what to do if the first argument is count. If I give it anything else, cal should still work. That's the original one. If I give it anything else, it'll just say that's one of those everything else that I don't know what to do with. So that's the case statement. Those are ifs. I sort of briefly did, and I'll show you the hands-on experiments because I offered you a whole bunch more than this in the hands-on experiments. But I also wanted to draw your attention to the super important thing. So I'm going to go back and do that. Yeah. Yeah, we'll go back. So the super important things about writing these if statements are the spaces. So where there's this square bracket here on line 11, you've got to put a space after that square bracket or it breaks. So wherever I put spaces in my examples, it's probably because they're required. So notice down here on line 17, same thing. Yes, so Justin asked, can I see task again? So yeah, I'll pop that one up and we'll look at that one. And I can talk about the spacing issue here. So be careful about the spacing of things. So if I don't have spaces, like on line 14, no spaces around this equals, don't put spaces. And if you get errors, it's probably because of the spacing. So you have to have spaces around inside of these square brackets up here on line 3. You cannot have spaces around the equals on lines 14 and 15. So Bash is somewhat sensitive about these spacing issues. So if you find yourself getting any kind of errors, try to go double check the spacing around the square brackets and around the equal signs. to make sure that you have those where you want them. Okay, no problem. Okay, so I'm going to do a switch, and then I'm going to switch back. So let me just show you what I'm about to Firefox. Okay, so first I wanted to show you the hands-on experiments. So this is the hands-on experiments. They are linked in the lab. Hopefully you're seeing that. Okay, yeah. So the hands-on experiments, the lab questions themselves have lots of scripting examples, but so do the hands-on experiments, and some of them are a bit more extensive. So let me just show you. Their screen captures. I guess I could probably put the text up. I did that because I wanted people to have to feel compelled to practice VI, which is why I did it this way. But be careful of the spacing. In this case, I want to show you this first example is using numbers. So the comparisons are using the dash, in this case LT for less than, the dash GT for greater than. That's because we're doing numerical comparisons. The other thing that this shows you, by the way, if in doubt, put quotes around your variables. If in doubt, you can save yourself a lot of hassle. So that's the first example. The second example is using the command line arguments and the positional parameters. This one has the $0, which hopefully you'll experiment with and discover what the special usage or meaning of $0 is. What else? So we have the third example. So has a number comparison section, then it has a string comparison section. And notice that I put day as all funky, and then I sort of offered a way to fix it. That's just to remind you about utilities, and then we do some string comparisons that use the regular operators, double equals in this case. And then the last one, string comparisons again, where we're doing less than, greater than, so that's alphabetical ordering. And then I have I had to piece this one together because it ran across two screens, so this whole tall thing is one script. But I was screen capturing off of my virtual machine, which, I can't get this long screen on it yet. So anyway, that's all one super long script, but it's actually sort of setting up for a larger to-do list type of program. So if you sort of want to experiment with making something bigger and more interesting, that's what this is for, and then I'll probably expand on that idea later. So there's really just those four examples. The last one is kind of hairy, but maybe it'll give you a chance to sort of think about what it is that I mean to be doing here. And I tried to do some interesting operations in there. Okay, so there's that. The other thing, just to remind you, the hands-on experiments have lots of goodies in it. So the other thing before I switch back is I'm going to use some of these file test operators here in a moment. And I want to show you the setup for a file test operator. So these are super useful when you're scripting because you can check to see if things exist, if they exist and they are executable, if they exist and they are writable. We can check to see if something is actually a directory, which should be somewhere in here. Oh, there it is. You can see if it's not zero size. So I just want to show you how those work. So I'm referring to all these file test operators. I believe they're also in your reading. Just to show you a couple of examples. Okay, so switching back to my virtual machine. So just about out of time, so I'll do just a couple of quick ones. And then I guess I gotta call it a day because I'm starting to eat into your time as well. I'll just call it files.sh. So I'm going to make one more folder. Hopefully I don't already have that folder. Before I do that, I'm just going to touch a file. So I'll just call it junk.txt, which is not executable. So just want to show you some examples. I'm also going to make it not writable. So just make it writable to nobody with chmod. So I'm removing the write permission from all user group and other. Just show it to you. So there's junk. It's readable by everybody. It's zero size. Not writable by anybody. So now I want to show you just how the file test operators work. Shebang it so that it always runs in. Alright, so these are pretty simple. So this is how file tests work. So in this case, in fact, let's use junk. So I want to know if junk is a directory. So again, the spacing, but this is how you use the file tests. They look a little bit weird, but you apply the test to a file or directory to learn things about it. So I'm specifically just going to check that junk file. You can also do backwards tests, so you can say if they're not something. So this is the opposite, so if it's not writable, I may have to take that space out, but let's just see. So there's a couple of different, let me put an extra blank line in there so you can read it better. So this is using the file test, but you can also use them as the inverse or the opposite of the question. So the -w test says, is that thing writable? If you put the exclamation point, that means is it not writable? Which it's not, because I made it not writable, so I'm hoping to see that output. And I'm also hoping to see the junk.txt is not a directory. Got to make this executable. So it's not a directory and it's not writable. That's what I expected because I made it that way. So these are how the file tests work. You apply the file test to a file. You can also do it to a directory. You can see if directories or files are writable. The most basic one is does the thing exist? So I'm going to test something a little bit different here. So this first one is simply a test for the existence of a thing. So does this directory off the present working directory exist? If it does, it will say it exists. If it doesn't, it will say no junk directory here. So there's just 3 examples of file tests. So no junk here. Now if I make the directory and I rerun the script, then it will say, oh, now it does exist. If I take it off, then it doesn't exist anymore. So there's a few examples of doing file tests. I'll bring this screen up. Actually, maybe if I just pause on this. So I'm going to run out of time, which means that hopefully I'll be more efficient with my time next week. But I will leave the instructions up. So I'll switch back to the screen in just a second. But just a reminder as I'm closing out here, if you go to the lecture page for this week, there's a link to a file called How to Install Display Managers in Desktop Environments. I meant to leave myself some time to do that today, but I'm already run over, so I didn't, unfortunately. But anyway, I will link the same file next week and try to make, time for myself to actually do it. But it does have instructions in it, if you are interested, in trying out some desktop environments and some login screens. So a display manager, which of course you can Google what's a display manager in Linux. It serves as a login screen, a graphical login screen, but at the same time it gives you the option of, if you have more than one graphical desktop, you can actually select between your different installed graphical environments at the moment that you log in. So that's quite cool thing to have. So I will come back to this next week and hopefully leave myself adequate time to deal with it. But if you're brave, you can have a crack at it. All the commands are here. I have tested them. I did leave a warning that at present I was able to install Budgie with no errors, but when I try to log into Budgie, I just get a black screen and I have to kill the system. So heads up about Budgie. Cinnamon works just fine, although they're RAM hogs. So if your virtual machine has a small amount of RAM, they're a little slow, but they do work. Anyway, so play around. The display managers allow you to swap out which environment you're about to log into, so be on the lookout for that. Usually there will be a little drop-down list or a gear icon as you begin to log in that lets you switch between your graphical environments. Okay, I got to stop. Thank you very much for sticking around as I went over a bit today on time. I hope you all have a great week. Hope the rest of your day is great, and I will see you next week. I will try to manage my time better so that I can come back to this display manager and desktop environment thing and actually do some of the walkthrough myself. Thank you, Justin. Appreciate it. Thanks all of you for being here. If you're watching later, hope that your week's gone well. And I will see you on Tuesday next week. So take care.